2022 SMT team test, Stanford math tournament. We want to solve this problem. Before solving the problem, I should tell you two theorems and then solve the problem. If you know the theorems, Vieta's formula and Newton's sum, you can use the time codes in the description and go straight forward to the solution. Okay, so let's read the problem. These exams are useful for your CV for applying university. So let's start and solve this problem. Let a, b, and c be the roots of the polynomial x cubed minus 3x squared minus 4x plus 5. Compute this part. So first, I want to use Vieta's formula. So let's apply that. I know x cubed, suppose it says the roots are a, b, c. So x cubed minus, if I write 3x squared minus 4x plus 5, it is equal to x minus a, the roots x minus b, x minus c. And if we multiply it, it will be x cubed and x squared. The coefficient of x squared will be negative a, negative b, negative c. Coefficient of x will be ab plus ac plus bc. And the constant term will be negative abc. And if you consider both equations like this and this, the coefficient of x squared, we conclude negative 3 equal to negative a minus b minus c. So a plus b plus c is 3. For x, negative 4 is ab plus ac plus bc. For constant term, 5 equal to negative abc. So we can say ABC equal to negative 5 because negative ABC equal to 5. Okay? So ABC equal to negative 5. Now, it was first part, Vieta's formula. We've reached three important things. It's first one, second one, and third one. Now, let's work on Newton's sum. In this part, we define SK equal to AK plus bk, b to the k plus c to the k. We define this and we want to find a recursive sequence for this. S0 is obvious, it's A0 plus B0 plus C0. And it will be 1 plus 1 plus 1 equal to 3. And we know ABC are not 0 because if it was 0, then the product will be 0, but product will be negative 5. So S0 is 3, S1 is A plus B plus C. A plus B plus C for S1 is, from first one, is 3. S2 is A squared plus B squared plus C squared. I can say it is equal to A plus B plus C squared. Now look at this famous identity. You should know this. A squared, A plus B plus C squared is A squared plus B squared plus C squared plus 2AB plus 2AC plus 2BC. So if I subtract, you should memorize it. If I subtract negative 2AB, negative 2AC, negative 2BC, then both sides are equal. A plus B plus C here is 3. So it is 3 squared, 9 minus 2 times AB plus AC plus BC. AB plus BC, AC plus BC by this part is negative 4. So it will be 3 squared, which is 9 minus 2 times negative 4. Negative 2 times negative 4 is 8, 9 plus 8 is 17. So we found S0, S1, S2. Now we want to find SK for general K, a recursive sequence. Our equation is x cubed minus 3x squared. Let's write x cubed minus 3x squared minus 4x plus 5 equal to 0. Minus 4x plus 5 equal to 0. Okay, so but when we have this, I know that a cubed minus 3a squared, because ABC are roots, minus 4a plus 5 equal to 0. I write it for b and c. B cubed minus 3b squared minus 4b plus 5 is 0. And I write for c cubed minus 3c squared minus 4c plus 5 is 0. Now if we add all these three equations, so the first part is a cubed plus b cubed plus c cubed. By definition, we said sk is what? Is ak plus b to the k plus c to the k. So if we add the first column, a cubed plus b cubed plus c cubed is s3 Now, this part, negative 3, a squared plus b squared plus c squared, it will be negative 3s2. This part, negative 4 times a plus b plus c, negative 4s1. 5 here, you can say s0, because a to the 0, b to the 0, c to the 0. S0 is 3. Okay, so some of them, look, 5 times 3, 15. We said S0 is 3. So 3 fives, 15. Okay. Right hand side, if you add these three equations, 0 plus 0 plus 0 is 0. So we conclude S3 equal to 3S2 plus 4S1 minus 5S0. I want to generalize this formula. Look, how I can generalize? If I, let me copy this equation. So now let's multiply them, first one by a. It will be a to the 4 minus 3a cubed minus 4a squared plus 5a equal to 0. Then we multiply this by b. B to the 4 minus 3b cubed minus 4b squared plus 5b equal to 0. This one, if we multiply it by c, c to the 4 minus 3c cubed minus 4c squared plus 5c equal to 0. Then if we add these equations, again, a4, b4, c4 is s4 by definition of sk. This one is negative 3s cubed. S3, this one is negative 4s squared, S2. This one is plus 5s1. If we take these things to right hand side, here it will be s to the 4 equal to 3s cubed plus 4s1 minus 5s0. Okay? We can do the same thing and multiply by a to the k minus 3. Then we will reach sk. Similarly, we can prove it easily. Only like this, instead of a, you should multiply by ak minus 3. Okay? So sk equal to 3sk minus 1 plus 4sk minus 2 minus 5. Here, sorry, it's 5s1. Let me correct. It is 4s2 minus 5s1. sk minus 2, 5sk minus 3. Okay? So let's write all things that we have. So we had these three equations, a plus b plus c is 3. A plus b plus c is 3. The next one, ab plus ac plus bc negative 4. Plus bc plus ac is negative 4. ABC, the product, these were with Vieta's formula, negative 5. So ABC, negative 5. Now we said SK is AK plus BK plus CK. We said S0 is 3. S1 is 3. S2 was 17, I think. Yes, 17. And we found a formula, a recursive sequence for SK. SK is 3SK minus 1 plus 4SK minus 2. 3SK minus 1 plus 4SK minus 2 minus 5SK minus 3. Okay, minus 5SK minus 3. And our polynomial is x cubed minus 3x squared minus 4x plus 5 equal to 0. Okay, minus 3 is minus 4x minus plus 5. Okay. Now let's calculate the rest. For example, if we need up to S5, you will see why. Let's calculate S3. S3 by this formula we have is 3S2 plus 4S1 minus 5S0. So it will be 3 times 17 plus 4S1, 4 times 3 minus 5S0, which is 3. So it is equal to, this one is 51, this one is 12, this one is 15. This one is negative 3. 51 minus 3 is 48. S3 is this. S4 is 3s cubed plus 4s2 minus 5s1. 3s3, 3 times 48 is 144. 4s2, you multiply 4 by s2 is 68, minus 5s1 minus 15. So if we calculate this part, it will be 68 minus 15, 353. Sum of them is 197. Our last part, 5s5, s5, 3s4 plus 4s3 minus 5s2. 3s4 is 3 times. Okay, so 3s4 equal to 3s4. If we multiply 3 times 7, 21, we have 2. 3 times 9, 3 times 9, 27 plus 2, 29. We have 2 is 591. And 4 times s3 is 4 times 832. We have 3, 192 minus 5s2 minus 85. If we subtract 12 minus 5, 7, 8 minus 8, 0, and it will be 1, then it will be 8, 9, 698. Okay, now we want to solve the problem. Okay, the problem says find a to the 4 plus b to the 4, this expression. Okay, from here I know a to the 4 plus b to the 4 s4 is sum of plus c to the 4 is 197. So I can say the first part, this part, is 197 minus c to the 4 over a plus b plus c, because of s1 or here is 3. So I can write the first one, a plus b is 3 minus c. I write similarly the next term, 197 minus a to the 4 over 3 minus a plus 197 minus b to the 4 over 3 minus b. Okay, now I use common denominator. If I use common denominator, it will be 197 minus c to the 4 times 3 minus a times 3 minus b and plus other terms, okay, divided by 3 minus c, 3 minus a, 3 minus b. So let's focus first on numerator. Denominator is easier. Let's calculate denominator first. 3 minus c, 3 minus a, 3 minus b. So 3 is 27. Now 3 times, for example, negative b. It will be, if you factor from negative 9, it will be a, because here it's negative b, negative a, negative c. Negative 9 times a plus b plus c. Then 3 times ab, ac, bc, you factor from 3, it will be ab plus ac plus bc. Minus c minus a minus b, it will be negative abc. Okay. A plus b plus c is 3. We had it here. AB plus AC plus BC, negative 4, and this part, negative 5. So, negative 4, negative 5. Let's replace negative 4, negative 5. So, if we calculate this one, 27 will be cancelled. It will be negative 12. Minus 5 plus 5, negative 7. So, we found denominator is negative 7. Now, let's focus on finding numerator. For numerator, we say, okay, 197 minus c to the 4, 3 minus a times 3 minus b plus, and also other terms. So I say when 197 times 3, we have this in also other two terms. So you say 3 times 197 times 3 times 3. Okay. Then when you multiply, for example, 197 times 3 times negative b, or times this 3 negative a. So you will say we have 1, 9, and 3 times negative b is negative, negative 3 times 197. Here we have a and b because it's related to c. In next term we have b and c. In next term we have a and c. So in general we have 2a, 2b, 2c. If it is hard, you can write other two terms and you will reach exactly the same thing, but I want to teach you this shortcut, and then you don't need to write all terms. So we have 2a, 2b, 2c. So you factor from 2, it will be a plus b plus c. And then you say 197 times negative a, negative b. It will be 197 ab. So we factor from 197, it will be ab plus ac plus bc. Now let's consider negative c4. When we multiply negative c4 by 3, it will be 9 times negative c4. So we can factor from negative 9, it will be c4 plus b4 plus a4. So we write like this for other terms also if you consider. Then negative C4 times 3 times negative B. So negative, negative, positive. So it will be 3 plus 3 C4A, C4B, C4B. Also, if you write other terms, you will see, for example, A4B, A4C. Then you can write for other terms B4A plus B4C. And then last part, negative C to the 4, negative A, negative B. It will be negative ABC4. So it will be negative ABC4 plus AB4C plus A4BC. Okay, now let's calculate. A plus B plus C is what? Is 3. AB plus AC plus BC here we've used negative 4. A4 plus B4 plus C4 is S4, and we found S4. S4 was what? S4 was 197, so let's replace. This part is what? This part is ABC. You factor C cubed plus B cubed plus A cubed. Okay. ABC is what from here is negative 5. A cubed plus B cubed plus C cubed is S3. S3 is 48. And for this part, look, I write it like this. A4 plus B4 plus C4 times A plus B plus C. So we have all terms but some extra terms. Like what? A4B, A4C is good because of here. But A4 times A is A5, so it's not good. So we subtract A5 plus B5 plus C5. So this part is S4, and S4 we know is what? 197. This part is 3. This part is S5. S5 was what? S5 698. Okay. So if we calculate, it will be 33327 197 times 27. 3 times 2 6 6 times 3 18 minus 18 times 197. The next one plus 197 times negative 4, or you can say minus 197 times 4. The next one 1 minus 9 times 197. The next one you say okay, 3 times 3 plus 9 times 197. 3 times this negative 3 times 698. And last part is negative negative plus 5 times 48. Okay, so here we can factor from 197 in all these terms. It will be 197. 27 minus 18 is 9. 9 minus 4 is 5. 5 minus 9 is negative 4. Negative 4 plus 9 is 5. Okay, this part is this. The next part is 3 times this. 3 times 8, 24. We have 2. 3 times 9, 27 plus 2, 29. We have 2. 3 times 6, 18 plus 2, 20 plus 5 times this. It will be 40. We have 4, 2, 40. And 5 times this is 5 times 7, 35. We have 3. 5 times 9, 45 plus 3, 48. We have 4. 5 times 1 plus 4, 9. This. And then it will be this part minus 200, 2094 plus 240. So if you add these two terms, it will be 5, 12. We have 1, 11, 12 minus 2904. So if you subtract 14 minus 5, 9. 8 minus 2, 6. And then 10 minus 2, 8. 1 minus 1, 0. So it will be negative 869. So negative 869 is numerator. So the answer is 869 over 7. It has also another solution, but this problem was good. You've learned Newton's sum and also. And the next problem, let me tell you the next idea, Vieta's formula. For Newton's sum, we have some other problems in AMC and also other exams. And for Vieta's formula, we have AMC, AME problems that helps you to improve your problem solving. If you want to know the other problems that you can do as homework to get good at Newton's and Vieta's formula, and also other ideas, we have 40, 50 important formulas in number theory, geometry, combinatorics, and algebra. If you want to learn them, feel free to send message to my WhatsApp number in the description comments. Okay, thanks for watching this video. Have a good day. See you next time.